So we know that in arteries, the net filtration pressure is out, meaning that it's positive, because we're talking about filtration pressure. Negative filtration pressure is reabsorption. Okay, but let's just use this as a drawing. The net filtration pressure is positive. In veins, we know that the net filtration pressure is negative, meaning that reabsorption is occurring, 20 liters to 17 liters. So the strongest force when everything is moving out, and we're not using up, down, we're using out and in, right? The strongest thing here, the big one, is going to be the BHP, the blood hydrostatic pressure, right? So that's, why is it higher here? Because it's closer to the heart. There's all this pressure built up still. It hasn't gotten reduced by resistance yet as it moves through all these little arterioles and capillaries and all this crap. So it's safe to say that later here, this blood hydrostatic pressure is actually pretty small, right? There's less. There's been all this resistance.
Because it's going away from the heart.
So something to bear in mind is this is the only thing that changes. All the rest of them are going to remain constant through this whole process. What's the main force that pulls fluids back in over here? It's actually still the same over here. BCOP, right. The blood colloid osmotic pressure, right?
That's what does what? Pulls.
It's you know how water gets attracted to proteins and colloids and things like that?
Yeah.
Well, water gets attracted to blood and all the crap that's in our blood, the fats and all that stuff, right? So BCOP, blood colloid osmotic pressure. Blood colloid osmotic pressure. It's actually going to be the same everywhere because the content of the blood is basically the same everywhere, right? Of fats and sugars and salts and right? There's going to be another force here, though, that wants to drive this out, and it's going to be pretty small, but it's significant enough to mention, and that is the interstitial fluid osmotic pressure, right? There's going to be osmosis wants to happen, let's just say it that way. There's a little bit of this that wants to happen. And then there's the thing that's almost essentially inconsequential that wants to also take it out, but that's the interstitial, that wants to put it back in. That's the interstitial fluid hydrostatic pressure. Just like the blood is pushing out, well, just a little bit of interstitial fluid's kind of pushing back in, right? So what we end up with is an equation. The net filtration pressure equals these forces that want it to move out versus these forces that want it to move in, right? What are the forces that want it to move out? Blood hydrostatic pressure and the interstitial fluid osmotic pressure, right? But it's going to be minus these forces that want to move it back in, which are blood colloid osmotic pressure and the little interstitial fluid hydrostatic pressure. Now, the only thing that changes is this, right? Blood hydrostatic pressure is the only thing that changes. Everything else is still the same everywhere you go, right? It's just changing because you're getting further away from the heart, so the blood hydrostatic pressure is lowering. So when you're close to the heart and you are in an artery, this is going to be big, right? So this will be a positive number, meaning filtration will occur. When you get further away from the heart, see how it's small? See how the BCOP is actually a lot bigger?
Yeah.
It's going to be a negative number. So that's negative filtration pressure, meaning it goes back in, causing reabsorption.